Hi, everyone. We are really pleased to participate at the ARM Dev Summit online event. I'm Eleanor. I'm a pre-sales engineer at Jenny Mobile, the company behind Genymotion and Android emulator. And this gives me the opportunity to talk to many people with different needs for mobile automation testing. And in my daily work, I advise them on how they can speed up the tests using different tools.
Hi, I'm Thomas. I'm a QA manager at Jenny Mobile. I'm in charge of improving tests in all our products. I'm also in charge of writing integration with several CI tools. Thanks to this, I discover new tools, learn new process, and I evolve my testing skills.
So in this presentation, we will provide you with best practices for end-to-end testing of Android applications. And this comes from our experience with our customers. You will learn the advantages of using ARM emulators for your mobile application testing to optimize your costs and achieve better test coverage. And you will see that there isn't one solution better than the other. It will really depend on the technologies that you want to use for building your testing environment or improving your existing one. So let's start with a bit of context on why we think that running tests on ARM emulators for testing Android mobile application is the future. So when developing and testing daily on Android, QA and dev engineers use emulators. And I'm sure that if you are in this field of expertise, you may already have faced many challenges and are looking for a solution. And currently, most of the computers are x86 based. So Android emulation solutions need to adapt to this kind of architecture. This architecture is completely different from the ARM architecture of real mobile device. So let's have a bit of history regarding the development of Android emulators. So more than 10 years ago, when the first Google emulator was released, it was ARM-based, but really slow to boot, as it was running on x86-based computers. And that's how we saw that x86 emulators like Genymotion started to roll out for quick boot and better performance. But while gaining performance, it all comes with a price. Not all mobile application is compatible. And engineers are facing issues when developing and testing native code. The application can be installed without extra configuration on those x86 emulators. And if you are in Android development, you may have already used unofficially supported ARM translation tools. But sometimes, even with ARM translation tools installed, the application won't run properly. So people get back to the real device plugged to the computer. It can become very expensive if the company needs to buy a phone for each of its employees. And it is still manageable for developing applications, but for scaling tests, it can become much more expensive. But this is changing. And for a few years, ARM-based computers and cloud servers are arriving on the market. And since last year, the number of these devices keep increasing rapidly. In the Android development world, there are a lot of people who are using Mac computers, and Apple shifting to ARM for its Mac computers is certainly accelerating the spread of ARM computers. And with ARM-based emulators available on ARM cloud servers, we can finally test on the same toolchain and architecture of a real device. You don't need to install ARM translation tools anymore, and testing native code becomes easy and bugs can be found sooner. And all the steps in the mobile lifecycle can now be done on the same architecture of a real device. Testing Android mobile application on ARM devices is one of the many tools used for mobile testing. And we are now going to provide you with the tools and methods for setting or improving your Android testing mobile strategy. And for that, I will hand this to Thomas.
Thanks, Eleanor. Before talking about strategy and tools, let's give a bit of context on why testing mobile apps can be time-consuming if not done properly. In your company, you are probably already using Agile methodology to develop and deliver your mobile application, which means that you build, test, and deploy more often than before. If you are a QA engineer, you may have already been more and more involved, and you have a key role on your application quality. We all know that an application failing to respond has a direct business impact. We see that more and more QA managers are adopting a shift-left strategy, conduct tests early to minimize the cost of the bug. Tests need to be automated, leaving manual testing for exploratory tests. Automating tests is not enough. Having a good strategy is the key. Key components of this strategy are choosing the most suited testing framework, the tools around automation, and how those tests are being run. Here, I will give you some examples of implementation where automating tests without any strategy is inefficient. Android and iOS applications need to be tested. You choose two different testing frameworks, Espresso for Android and Appium for iOS. Also, you could choose Appium for both and have common testing code for both app versions. Automating tests without any continuous integration environment, and automating tests in several batches without any parallelization. You have to wait a long time to get results. The most used testing framework for Android mobile tests are Espresso, Appium, and Detox. All of them are able to test native and hybrid applications. Appium can also test web application, and Detox is known for testing React Native application. Espresso is essentially used by developers because Espresso needs to have access to the source code. It is used only on Android, and it supports Java and Kotlin language. Appium and Detox philosophy is to test as a real user. They are most used by testers because they don't need to have access to the source code. Another advantage is that they are used to run tests on Android and iOS with the same script. So we have talked about testing framework used for writing tests, but we need a CI server to trigger those tests. I will let Elinor talk about this.
Thank you, Thomas. So yes, CI servers play a central role in the mobile development application lifecycle, as it is the orchestrator of building the application, start the devices, and run the tests. And we see that there is a tendency for cloud solutions because it is easy to set up, the infrastructure is managed for you, as it can be really time-consuming to configure an on-prem server if there aren't any experts in your company for setting everything up and, of course, maintaining it. And there are several continuous integration servers out there. And some of those CIs are Bitrise, which is a cloud-based CI server dedicated to mobile. There is a user-friendly interface to create job workflows, which is quite intuitive, ideal for people that are not very familiar with creating jobs with configuration files. But of course, if you prefer to configure jobs with files, you can do it with YAML file. We also have Circle CI and GitHub Actions, which are cloud and also on-prem, and you can use YAML file to configure your jobs. And indeed, once you have chosen your testing framework, written your tests, and chosen a CI server to run those tests, you need to choose on which type of devices to run them. And what we often see is that people are using a hybrid approach, physical and virtual. Why? Because they are complementary and have both pros and cons. And what we see is that for daily tests, people tend to use virtual devices. Indeed, we can use APIs to test the application in various conditions. For example, doing image injection, which could be hard with physical devices. And as we need to test often, we need to be reactive and have devices always available for the test in order not to block a pending pull request. And we also see a tendency to move to the cloud to avoid all the hassle of managing infrastructure and, of course, to achieve better scalability. And having ARM emulators available on ARM cloud servers helps scaling the tests. But we know that with virtual devices, we can't test device manufacturer-specific layer. So usually we use real devices before a new release for full validation. I was talking about emulators, and Genymotion device image is one example of cloud ARM-based Android emulator. You can interact with a device manually from a web browser for exploratory testing, for example, or automatically when CI job triggers the start of the devices and runs the test on it. And as it is on the cloud, the number of devices can be easily scaled up and down to achieve better scalability and reduce your testing time. And Thomas will talk more about how to scale tests later in the presentation. And as you can connect to Genymotion Cloud devices directly with an NDB connection, the integration is quite seamless. You can run your tests as if you had physical devices plugged to your CI. It is available on AWS, Oracle Cloud, also available on demand on Ampere ARM servers. You have now all the tools to build your Android testing strategy. So yeah, let's talk about how you can reduce your testing time by parallelizing tests to better test at scale. And for that, I will hand this to Thomas.
Thanks, Elinor. So we'll talk about why you run tests at scale. Running tests at scale will improve the test build time, and you can get the result as soon as possible. Running tests at scale will also allow you to test your application with the same or different Android version. As you may know, functional tests can take a long time, depending on the number of tests you have, the number of Android version you want to test. It can be annoying to wait for the result. That's why we encourage testers and developers to scale the test using parallel testing method or test sharding. Let's talk about parallel testing. Imagine you want to run your test on several Android versions, Android 8, 9, 10, 11. The goal is to start several devices at the same time and run tests on all of them. The benefit is you will improve your test coverage and you will be sure that all your scenario will work on all Android versions you target. It can be useful to run tests in parallel before a release. Parallel testing is easy to set up with almost all testing frameworks using library like PyTest or Python for PyTest for Python or TestNG for Java. Now let's talk about test sharding. The purpose of doing test sharding is to spread tests across devices and ease the testing workload so that you can execute automated tests faster. Imagine that you have 100 tests taking 10 minutes in total to complete on a single devices. Now, what if we divide these 100 tests to get them run on 5 devices? 20 tests for each devices. It will take 2 minutes rather than 10 minutes to finish the test session and get the test reports. This method can be useful when development is in progress and you want to catch bugs earlier. For example, when you push a pull request or a commit. You don't need to run those tests on each Android version, but you want to be sure that they are working. The sharding is easy to set up. You can use the Android instrumentation runner or Spoon for Android. We hope that you all know now have a good overview on the tools and advantage of running your Android mobile test on ARM.
Yeah, this presentation was quite high level, but we hope that it will help you build or improve your testing strategy. And of course, if you want to have a more deeper technical understanding, don't hesitate to reach us. We will be happy to discuss that. Thank you very much.
Thank you very much, everyone.